Right, guys? I think we're good to start here. Just going to go straight into this first talk here. There's a few new faces tonight, so I'm just going to give a quick introduction. My name is David Frame. I work for a company called 31 Interactive. I've been working there for about 2.5 years now, I think, roundabouts. And I've been in the industry for about 12 or 13 years, something like that there. And it's been a web development and software development stuff. It's been a personal hobby of mine for many years before that. So this talk I'm going to give is on dependency injection. It's a term many of you have probably heard of before. Many of you have probably implemented it before. The top subject, it's quite dry. It is a programming theory thing. So, you know, manage your expectations. Okay. I'll try and race through. I'm not going to sort of dwell on some subjects. I'm going to race through it as quick as I can, just try and keep the interest up. So, without further ado, let's go. Here's a little bit of code, and it's fairly simple. We've got a class, it's called order. It represents an order in a system, an e-commerce order, say. It's got one method called complete. It sets a property of completed to be true. It creates this mailer object, and it sends out an email, like an order notification thing, right? So, you're probably wondering, well, what's actually wrong with this? You know, is there anything wrong with this code? The answer is no, there's nothing wrong with this code at all. It works perfectly. This could be used in production, and it's worked fine up until now. Perfect, no problem. But there's a sort of limitation to this code moving forwards, okay? And I'm going to start explaining over the next few slides what that limitation is. So I want you to consider a scenario here. We need to be able to test our order class without sending any emails, okay? Imagine you're either doing some sort of automated testing using a testing suite or something like that, or you're just doing manual testing yourself, running manual tests on your system just to make sure everything's working, okay? The problem is, you hit that class, you hit the complete method, and it fires out an email to somebody every single time you test that class. No, you don't want to do that really. You don't want to be sending an email each time. So what do? Well, there's two solutions to that problem. First of all, you could go into your mailer class and you could comment everything out. So that mailer class no longer does anything, right? Not a great solution because your mailer class might be used by some other part of your application, right? You don't want to break some other part of your application just to do this. There's also the problem that at the end of the day, your mailer class, you already know from your sort of previous testing, it already works, okay? That mailer class works exactly as it's supposed to, so you don't want to be changing that. You don't want to change code that you know already works just for the benefit of doing additional testing. It's a really poor approach. So the next solution then would be this. And you'll see it's here. Now we have a dummy mailer class. So this is exactly the same code as we had before, but we're just using a different mailer, this mock mailer. That mock mailer is going to have a send method, but it's not going to do anything. Okay? It could maybe send, or could maybe store the information in a log file or something like that, or just do nothing at all. It doesn't really matter. Now, this is a far better approach, and yeah, so you're not changing your original mailer. It's a far better approach for doing this. But there's still kind of a problem here, really. And if you remember back to what I said before about the previous mailer we already knew worked, and we didn't want to change it, we've just done the same thing here. This here file, we already know it works. Okay? We don't want to start fiddling around inside this and changing this to do something else just so we can test it in the future. It's a really poor approach. So then what is the solution to this? Well, in this scenario, there really isn't a solution for this code. However, if the code had been developed in a certain way to begin with, it would have made this possible. It would have made it far easier to actually accomplish what we're trying to do here without messing up things that we already know about that works. Okay? And the solution to this is dependency injection. And if you've never heard of dependency injection, you don't really know what that is. Sounds like a complicated term, right? Like a sort of technical kind of what? But it's actually quite easy to understand if you just break it down. Dependency. What is a dependency? Let's go back to your previous bit of code here. Our order class depends on mock mailer or mailer class, whatever that may be. It depends on that. It needs it to work right. Okay? So we could say that mock mailer is a dependency. It's a dependency of the order class. So that's one thing down. Second thing, injection. Injection implies then that something will be supplied to something else. So our mock mailer or mailer will be supplied to order. That's not really how it's working at the moment. Our order class is creating our mock mailer inside it, and its implementation is creating a concrete abstraction of this. We don't want that. But we can inject it instead. We can supply it to our order class. How do we do that? Pretty simple. Pass it in. So we've updated our order class now with our constructor. We've got another property called mailer. We're passing our mailer in the constructor as a parameter. We're setting the property of mailer then, and in our complete method, as before, instead of creating a brand new mailer class, we're just doing this mailer property, send, and whatever. Now this actually solves our original scenario completely, because we're no longer having to edit any code here. We're not having to change our order class or having to change our mailer class. All we need to do is create a new mailer. We don't care what it does. It could, like say, it could do nothing. It could write to a log file, whatever. We simply pass it into our order class, higher up the chain. So we still do need to create this at some point, but it'll happen earlier on. It's not going to happen inside our order class. So this in a nutshell is dependency injection. It just makes it it's a more flexible way of doing things, as you'll see in the next while here. So there's our solution. And this solution, this idea of dependency injection, covers 3 principles. Now, if you've heard of the solid principles about object-oriented design, there's sort of principles to make object-oriented code more reusable and just better code in general, and they've been floating around for quite a while now. So 3 of those principles are in use here in dependency injection. The first one is the single responsibility principle that many of you I'm sure have heard about. It is that a class should only have a single responsibility. So if you think back again to our previous order, within our order we were sending an email, and suddenly our order class was thinking about, it wasn't thinking about being an order anymore, it was thinking about how do I email. And we were sort of setting this email class to be, this mail class to be whatever within our order class, when it shouldn't really belong there. In fact, there's an argument that the order class shouldn't be worried about any email whatsoever. I shouldn't be doing any sort of email from our order class, because that's not its responsibility. Its responsibility is to be an order, that represent an order on our system. So the mailing process itself should probably even happen outside of that, but that's another matter. The fact is, it certainly shouldn't have cared what type of mail we were sending. So single responsibility principle. Next one is the open-close principle. That is, software entities should be open for extension but closed for modification. This is more tricky. Best way of thinking about this one is, if you imagine that our order class was part of a component that we'd written, like an open source component that other people could bring down into their own projects. That's fine, right? It's like we come in through Composer or whatever else, whatever other package manager. But say the consumer of that component, whoever that may be, somebody on the other side of the world, doesn't matter, needs to change that mailer class. How do they do it? In that case, they can't. All they can do is edit your own code, edit the code you've created, which is a big no-no. You should never edit vendor code, because any changes you make could easily be lost the next time you decide to upgrade those packages or that component. So don't edit vendor code. It's a poor approach. And open-close principle sort of factors into that. It implies then that people should not be able to edit your code. The way your code is built, it shouldn't be open to modification in any way. It should be completely closed off. And to facilitate that, it should be open for extension, i.e., whoever's consuming your component can pass in a new object, or can extend a class in some way and add a tiny little bit of extra functionality into that, whatever else. So dependency injection actually facilitates that in a certain way, because you're passing in your dependencies into a class rather than creating inside of your class, if that makes sense. The next two ones, list cost substitution and interface segregation, aren't really used in this here, so we're not going to concern ourselves with them. Dependency inversion principle: once you depend on abstractions, do not depend on concretions. That pretty much encompasses what we just did. So beforehand we were depending on a concretion. We were creating a concrete class within our order. Bad, don't do that. Depend upon abstractions. So we were passing in our mailer class into the constructor of our order, which is great. We could have went further with it, and if you see code out in the wild that's using dependency injection, you will often see that anything that's passed in, any dependencies that are passed into a constructor or a setter method or whatever else, will be type hinted as belonging to or as implementing a certain interface or extending a certain class or whatever else. And that is depending then on abstractions. It's not depending on concrete classes. So dependency inversion principle, that applies to dependency injection as well. Now, close to the end of this, I'm just going to run through another quick scenario, which is now we need to store emails in the database so that they can be queued up and sent at a later date. Right? It's kind of a silly scenario, silly example, but it's one nonetheless to demonstrate this point. So how do we do that? Well, you already kind of know. We've got a database mailer that we're going to pass into our order class. That's fine. So we define our send method here. Then we do database equals new database, localhost database instance. Oh, but hang on. We're doing the same thing again. We're creating an object inside of our database mailer class. This is the wrong approach. We already know we're not supposed to do that. So let's use dependency injection again. Now we're passing our database into the constructor of our database mailer. So this is far better now. If you have a different database implementation, you can just pass it into your database mailer, which can then be in turn passed into your order. And you can sort of see, well, hang on, things are getting a wee bit complicated here. We're having to create these objects somewhere in our application and then pass them into each other just to get to an endpoint somewhere. And that is indeed a problem. In this case, it's not too bad because there aren't many objects. This here file could be like a bootstrap file. It could be an initialization script or something that runs at the very start of your application. Yeah, the first file on chain or somewhere around that. So we would create a database, create a mailer, pass in our database into the mailer, create an order, silly example, pass in a mailer into our order, and then do order complete. Right, that's a lot of work. When you think about it, like what did we have to do before we came up with this whole dependency injection thing? We just had to create a new order and call complete. That's all we needed to do, but now suddenly we're having to create new objects in the background. So you can imagine in bigger applications, this becomes more and more of an issue because you've got lots and lots and lots of objects being created here, passed into other objects, and it just becomes a bit confusing and a bit messy. So smart people came up with this quick solution, which is dependency injection containers. And dependency injection containers are essentially a lookup guide, right? They run in the background of your application. You can set up certain rules to say, if I need an order class, I need you to provide it to me with a mailer passed in, which also needs to have a database passed in. Right? Sounds confusing. Hopefully everybody can see this here. Our first file here, this is our original bootstrap file again, but now it's broken into two. So we've got a file, say, called services.php and then bootstrap.php. Our services.php file, first line there, we're creating a container. That could be something you brought in through Composer. There's plenty of containers, IOC, or dependency injection container components out there that you can make use of. If you're using a PHP framework, it probably has its own built-in as well. So we're creating a container. We're saying within our container we define a database mailer, and we say a database mailer returns the result of this function, which creates a new database, creates a new mailer, passes in the database, and returns our mailer. What that means then is that within our initialization script, we require inner services, we create our order right here, order is new order, and then fetch database mailer from the container. And as soon as we do this, as soon as we call this fetch method, the system goes up, it creates that database object, it creates a database mailer object with the database passed in, and it returns it. So what you're actually passing into order here is our database mailer. It accomplishes exactly the same thing we saw a couple of slides ago. And then of course we just call order complete. Now there's an awful lot more to dependency injection containers. They can accomplish a hell of a lot more than just this. And there, like I said, there are plenty out there if you want to take a look at what is out there and how they can be configured. But that is kind of in a nutshell what they accomplish. And that's, to be honest, that's about it, guys. That's dependency injection. And there's not really a whole lot more to say on it. It's something, sorry, I meant to preface the talk with this here. This is not something that everybody necessarily needs to apply to their projects. If you imagine, if you're making up a small website for somebody, a client, yourself, whoever, and it's quite a small project, and you're not really going to be doing too much maintenance on it or testing on it or whatever else, you don't really need to be using dependency injection. Okay? This is more for projects that are bigger in scope, maintained over a course of months, years, whatever. Could be worked on by several team members, several individuals. If you're working, like I said before, if you're working on like an open source component that you're planning on publishing somewhere for other people to bring in, it's an absolute requirement. You have to be using this stuff. Nobody will use your component otherwise. Or they'll figure out that it's not worth using and then they won't use it. So it's worth bearing that in mind if you are going to do some sort of open source component like that, or any sort of reusable component really. And the final thing as well is that even if you don't foresee yourself needing to use this in a project, whether it be dependency injection or containers or whatever else in that sort of ecosystem, if you don't feel like you need to use these, it's worth knowing about it anyway. Because inevitably at some point in time, you'll need to look at some vendor code. You'll need to look at a component you've brought in that you're using in your project, your application. You're going to need to try and understand how it works, either debug it or figure it out for yourself. And you're going to see this a lot. You're going to see a lot of objects being created and passed into other objects. And if you're not used to that, if you're not familiar with that, it'll be really difficult to follow the flow of an application or a system. If you are more familiar with it, you sort of know what to expect. You're never going to expect to see classes or objects, like service-based objects created in other objects. It doesn't, service-based object created in other classes. It just doesn't happen. And if you're sort of prepared for that there, you can, like I say, you can better follow how things are working. So that's it. Thanks very much for listening, guys. If anybody has any questions, feel free to fire away. My email address and Twitter handles are right there. And if you'd like to review this talk, I know it's fairly short, but if you'd like to review it, the join in URL is right there. And there we go. Hope you enjoyed. Does anybody have any questions about dependency injection or anything like that? Go ahead.
Just on the idea of the containers there.
Yeah.
So at the start, you're kind of defining what the dependencies for this class is, and you're instantiating a bunch of objects.
Mm-hmm.
Is that not slightly scary? Because in bigger applications, you have all this kind of state stored globally, and if if you modify a dependency in one of the classes, then you're modifying the dependency for every one of those.
Yeah.
Does that cause problems?
It's not something I've personally run into, but I can definitely see how that could be an issue. It's sort of the dependency or the container idea. It doesn't really make the problem that much easier to deal with, because at the end of the day, you're still going to be creating an awful lot of objects in the background. That services file you saw before, it's just going to be huge. It's unavoidable. As the entry point to an application, it's just going to be massive, and it can be difficult to navigate at times. Like you're saying there, if one of those classes changes for some reason, if one of the, say like one of the parameters in the constructor changes from a mailer to something else, and the mailer gets pushed to be the second parameter, then suddenly that all breaks. So yeah, it can be an issue. You do have to sort of follow along with your code and constantly be thinking about the structure of your code and how certain changes you make would affect other parts of your application. When it comes to, it brings up the whole thing about backwards compatibility, I suppose. And again, that's not really something you need to worry about if you're just creating a website for somebody. But if you're making, again, a component for somebody, and you change the order of parameters in one of your classes, you just created a backwards compatibility issue, BC break. So that tends to be something it's not frowned upon, but it's something people are generally very, very careful about whenever they're pulling that package into their project or updating the package in the project. So yeah, there are definitely issues about it, but they can be prevented just by having a good handle on your code, how it works, and whether the changes you'll be making will actually be breaking other parts of it or breaking systems that may be using them.
Cool, thank you.
Anybody else? Cool. Excellent. All right. Well, thanks very much, guys. And I think that's us. What are we doing? Are we pressing ahead with Paul's talk now, Tim, or?
Possible, yeah, we could
just on that, I mean, I don't know if you want to talk about how that is handled by different frameworks, or is that a whole different topic?
It varies, that's the thing, it kind of varies. Say something like Laravel, which is the framework I'm most familiar with. It has its own dependency injection. It's called an IOC container. It's kind of much the same thing. It's just a different naming convention. And it does funny things like, say you have, if you go back to our order class, for example, we're pulling in, or we're having the mailer as a dependency of that order class. Forget my own code here. So the mailer is passed in to our order class. And if you remember back to how it was, here, sorry. So in this case, we're not really doing anything with mail. You remember I said about how you could maybe say this is like an interface, type it to be an interface or some sort of other abstraction. In something like Laravel, it has this handy feature of, I think it's called like smart resolution or something, or intelligent resolution or something like that there, where if you say that our mailer is going to be a, if you set it's a mailer interface, so any mailer that gets passed into this has to implement a certain interface in PHP, which will have, well, it'll say something like it has to have a send method, for example. So you'll type in that as public function construct, open bracket, mailer, space, mailer, right? So it has to be a mailer. Laravel has this thing where in the background it can say, right, this class is expecting a mailer, and I know that I have a default implementation for that mailer. So it'll actually pass in your dependency for you in the background without you having to do anything. It'll create a mailer for you and pass it in whatever class you're using. So this is, I think some other dependency injection containers and things actually do this for you as well. So it's, again, it's emphasizing that there's more to this subject, but the general gist of it is simply just passing objects in to your classes rather than creating them inside your classes. Another thing you'll find, and this isn't framework specific, but this only really applies to things that are you would consider to be maybe services, right? So we pass our mailer into this order class, but we might not necessarily need to pass in, say our order class creates an order record or an order log or something like that. There, just another class that hits a database or something, whatever it does. We don't necessarily need to pass this into this class here because it's kind of an entity in our system. It's not really a service per se. So it's not as big a deal to create something like that within our class because it's not something that you would really need to change at any point. right? It's a representation of a data element. So you don't need to pass that in. It doesn't even really make that much sense to pass something like that in, because it might not even be created yet. If it's an entity and it's represented in the database in some way, it doesn't exist. So how can you pass it in? You can pass in maybe something like a factory or a repository or something that is a class or an object that will allow you to create further classes, like a log factory or something like that, whatever, and maybe work it that way. But it's not a big deal as creating something like a service, like a mailer or a logger or whatever, any sort of service you can think of. It's more of a dependency injection is more suited to those sorts of service-based classes and objects in your system, not so much entities. In terms of other frameworks and things, I don't know, because I don't really use that many other frameworks, to be honest. I know well, Symfony use Pimple?
No.
Does it? Pimple's different.
Pimple's for Silex.
Oh, is it? Right, Symfony has its own thing.
Right. The service container in Symfony, you would define all your services through a YAML file, generally speaking, and it can be quite intimidating the first time you see it.
Because it's the same sort of thing there, where you just specify a class and then say this needs to be whatever. And
pretty much, you start off with your class name and then say this is what this class expects to be passed in, so you can have that sort of trickle down effect.
Yeah, I imagine it would get pretty large.
You would tend to have, you would split it out, so you would have your core application services YAML file, but then different parts for your own part of the application rather than the framework as a whole. You would have your own services file and other things that your common composer will have their own services YAML files, so all these service YAML files, and they all sort of chain together then.
So everything in Symfony itself, the framework, is kind of controlled in that YAML file, so you can override them?
Yes.
Very good. Yeah, so frameworks tend to have their own implementations. Some will use, there's, like I said, there's one called Pimple, there's one called PHPDI, I think, something like that, which is quite popular as well. And they all offer their own sort of little features and niceties and things like that there. But there's plenty out there to choose from and plenty to investigate if you feel you want to do that. And so there we go.